Hi, in this video I'll talk about unit vectors. The definition is very easy, but you will see why these are important for us. Okay, so to start with, just recall that a vector are directed line segments, and just by that definition you have, for any given vectors, we have two property. One, the length of the vector, which is what we denoted by this notation, and then we have direction. Well, how can we formalize the direction of a vector? In the two-dimensional case, when you have a vector, when we say, so let's say this is a vector, then, this is a key point, that all the vectors which are positive scalar multiple of each other. So this one, and then this one, all of them have same direction. And that means that every point on a circle centered at the origin gives us basically one direction. This is one direction. That's another direction. That's another direction. Just to have pure direction, basically what we need to do is choose a point on the unit circle. So every point on the unit circle, well, means that a circle centered at origin with radius 1 gives us a direction. So that is a direction, and that's the other way around is also true, and vice versa. So every direction gives us a point on the circle, unit circle, and the other way around. Well, these points actually, they have something more. These, if we take the position vectors of these guys, these are basically vectors of length 1. Remember that length of a vector at the standard position is the distance of the head from the origin. And if you choose a point on the unit circle, the distance of that point from the origin is 1. So this means that directions basically are in one-to-one correspondence with vectors with length 1. And well, that is the definition of unit vectors. So basically, unit vectors tells you what are the directions possible for those vectors. So let me just write the definition this way. Definition: vector U is called a unit vector if its length is 1. Well, for example, we can check if a vector is a unit or not. Determine if the given vector is unit or not. I have three vectors actually. One is in our 2, 3 over 5, 4 over 5. The other one is here, 1, negative 1, 1, 1. And our 3 are 4, and the other one is a 0, 0, goes up to 0, last one, 1. Or for any n, you take any components, number of components. Okay, let's do this one. What we need to check is the length. So length of this vector is you find square of each component, add them, and find the square root. That gives us 25, 9 over 25. That gives us 16 over 25, and then add them. This is 25, 9 plus 16, and basically we get root 25 over 25, which gives us square root of 1, which is 1. The length is 1, that means that vector is unit. How about this one? 1, negative 1, 1, 1. Find the length. So 1 squared plus negative 1 squared plus 1 plus 1. And if you do square all the components and add them, you get 4. Root 4 is 2. This is not 1. That means that this vector is not unit vector. And this vector here, so the length is, let me just write u. The length is first component is 0, second is 0, up to second last one is 0, but the last one is 1. So if you square them, you get 0 for all the components up to the second last one, and the last one gives us 1. So square root of 1 is 1. This is unit vector. Actually, this last example is a part of a series of good examples of unit vectors. It's called standard unit vectors. How do you, what are these vectors? Well, first of all, for any Rn, we have n of them. We denote it by E1, E2, up to En. And how do you make those ones? For E1, you put 1 in the first one and everything else 0. When you find the length of E1, obviously all the components other than 1 will give us 0. For the first one, you get 1, and that is 1. E2, the first one is 0, the second one is 1, the third one is 0, and it will go down all the way to the end, 0 components. And En, well, and you see E3 is now 0, 0, the third one is 1, the rest is a 0. And for the En, we have these guys. We'll get back to these standard unit vectors very soon. You'll see that they have very good property. Okay, now the question comes that, okay, if you have a vector, for example, this one, which is not unit, then how do you find a unit vector, or basically what is its direction? This is what your book likes to call as normalizing vectors. So normalizing a vector, normalizing a vector. Well, so if you have a vector for any non-zero, you'll see why we say non-zero vector in a second, vector u, we can always make a unit vector. So there exists a unit vector with the same direction. Unit vector with the same direction means what? It is a vector which is a scalar multiple of u. But to have a unit direction, we take the length of u and multiply 1 over u to u. This way, the vector we are finding, first of all, has length 1. So let me just write here. 1 over length u is a unit vector. Why is that? Because we can find its length. Yes, so this is 1 over length of u times u. And remember that if I have a c multiplied to u, the absolute value of c comes out. And then we multiply it by length of u. So this is the property that length of cu is absolute value of c length of u. But length of u is positive, 1 is positive, so 1 over length of u is a positive number. It means that, well, we can just drop the absolute value. Absolute value only turns negative numbers to positive. It keeps positive numbers the same. So this is length u, this cancel, and you get 1. So that's why this is unit vector. And also it has the same direction as 1 over u. U has same direction as u itself. And that is obvious because you see that absolute value of 1 over length of u is a constant number. So c1 over length u is positive. And 1 over length u times u is basically c times u for some c positive. It means that this guy is a multiple of u with positive multiple. And we know that if you multiply a positive number to a vector, the direction of the vector stays the same. Well, let's just do this operation, this work. This is called normalizing. So we normalize a vector means that we divide that vector by length of the same vector, or in other words, you multiply the vector by scalar 1 over length of u. Well, for example, in this case that we had here, then the normalized vector would be 1 over length of 1, negative 1, 1, 1 times 1, negative 1, 1, 1. And this is 1 over root 4, 1, negative 1, 1, 1. And that is 1 over 2, negative 1 over 2, 1 over 2, 1 over 2. So this is normalized vector. Again, you have to know what is a unit vector, how to check a vector is a normal or not. And also you have to be able to normalize a vector. It means that if it is not unit, you have to be able to find a vector which is unit and it has the same direction. This is the process we mentioned there.